We have a freight train that travels 210 miles in the same amount of time a car travels 330 miles. If the rate of the car is 20 miles per hour more than the rate of the train, find the rate of each. Anytime I have one of these problems, I like to use a distance equals rate times time table. So let's go ahead and set this up. We're going to have two trips. We're going to have one that is the freight train and one that is the car. So we know the train travels 210 miles. So train is 210 miles and the same amount of time a car travels, 330 miles. So this tells us two things. It tells us the distance, but it also tells us that the time is the same. We don't know that time, but since it's the same, we can put t in both places. Next, the rate of the car is 20 miles per hour more than the rate of the train. So we have whatever the rate of the train is, and we know the car is that rate, plus it goes 20 miles per hour faster. So that will be our table setup. Now I'm tempted, since I see t isolated here, let's go ahead and rewrite this equation, distance equals rate times time, and isolate t. We can divide by r on both sides, so those cancel and I end up with t equals d over r. And that's exactly what I'm going to do with these equations. All right, so t equals d over r, which would be 210 over r for the train. And then for the car, we'll have t equals d over r, so 330 over r plus 20. Okay, now these both equal t. Well, since these both equal t, we know these both must equal each other. So let's set that up. We have 210 over r equals 330 over r plus 20. Whenever you have a fraction equal to a fraction, you can just cross multiply. So we'll get 210. I want to make sure to put that r plus 20 in parentheses, so the 210 multiplies by both terms. And then equals 330r. Let's multiply this out. We get 210r plus 210 times 20 will be 4200 equals 330r. Now that we're simplified, let's get our variable terms on the same side. So we'll subtract 210r from each side. So those cancel. I'm left with 4200 equals 120r. I divide by 120 on each side. And so then r is going to equal 35 miles per hour. So that tells us, if we look at our table, we know r was the rate of the train. So then we can say the train goes 35 miles per hour. We know the car is 20 miles per hour faster, so we can just say, okay, 35 plus 20, so then the car would be 55 miles per hour. You can always check this in the problem and make sure that distance does equal rate times time for each of these, and that's a way to check that these answers are in fact both correct.